Greetings from the bridge of the Starship Enterprise. My name is Dion van Aert. I'm from Solutions PT. And with me today is, we've opened a subspace channel all the way to Ireland, and joining me today is Liam Deasy, all the way from NeoDyne. Hi, Liam.
Hi, Dion. Good afternoon.
How are you doing this afternoon?
Very good now.
Okay. Good to see that the subspace channel is at least working today. That seems to be stable. This is, of course, a webinar we're starting this afternoon as part of our 11-week webinar series in our Edge to Enterprise releases of our AVEVA 2020 software. We would like to welcome everybody on the call today. Thanks for joining us, and we hope you're going to enjoy the webinar with us. Okay. Well, Liam, you are from NeoDyne and one of our system integrators. How long have you guys been with us?
So I've been working with you for the last 9 to 10 years, but the relationship goes back 20 years almost to the foundation of NeoDyne as a company. So.
Right. So quite a long-standing and good relationship. You're very good friends of ours. You're well-versed in system platform and in all the previously Wonderware technologies. And it's also a very special occasion for NeoDyne. You've just been approved as endorsed system integrators. You just become endorsed system integrators. What does this mean to you guys?
It's, to be honest with you, it's critical to us. You know, it's the next evolution on our journey with AVEVA and with Solutions PT as well. So I just want to say thanks very much, Dion, to yourselves and AVEVA and Solutions PT. We appreciate the recognition and the confidence that you guys have shown in us, and we're looking forward to working with you, you know, on the next steps forward on that journey, as it were.
Right. And of course, as endorsed system integrators are like the top tier of system integrators that belong to our system integrator program. So well done, guys. We really love working with you, and the big reason is the kind of service and the kind of solutions that you provide using the technologies that ourselves and AVEVA provide to you. So well done in that respect. Well, today we are talking about Lakeland Dairies. So would you just give us a quick introduction, Liam, into Lakeland Dairies and what this project was all about?
Yeah, so Lakeland Dairies are one of the major milk processing companies across Ireland. They're processing approximately 1.8 billion litres of milk annually. They have specialist expertise in UHT, ice creams, butter fats, and they're servicing markets across the UK, Ireland, you know, the Americas, Europe, and Asia. And I suppose Lakeland Dairies came to us initially as part of a phased project which has been evolving over the last nearly 10 years, looking at control system upgrade and associated MES type functionality for a new process cell in one of their sites. And you know, they had seen the type of MES type solutions we were offering to some of our other customers, and said that, you know, this to them seemed like a good opportunity to implement that on their site in a greenfields process cell and see what value could be gotten. Since then, we've scaled that system out further across that site and to another Lakeland site in the, you know, on the southern side of the Irish border. You know, gradually scaling up the solution, modernizing it with you know, new functionalities that have come on stream over the last number of years. So that's kind of the little bit of background or the context, I suppose, Dion.
So that's quite a number of years that the system has been evolving. So it's been quite a while, and that it's been going on. So what is the components that made up your system, or how did you envisage the system to be made up?
Okay, so in our typical solution, what we have is four, very high level components that you could think of. So you have your control system layer of the solution, which in the case of Lakeland Dairies happens to be Siemens S7 series PLCs. That's the site standard for new technologies going in. But also a whole plethora of other pre-existing hardwares or other control system technology that pre-exist on site. So that was kind of your control system, your automation layer. Stepping up from that, then we call the SCADA MES component, which is AVEVA System Platform, which is what we're primarily looking at here, using AVEVA InTouch as the primary front end from the operator perspective. And this software all hosted on a virtualized environment delivered to the plant floor through industrial grade thin clients. The next main component then was you had supporting that was the database. So in the solution, we're leveraging Microsoft SQL Server as our standard database, and that's then supporting the infrastructure from the previous layer, the SCADA MES. That's presented to the front end through .NET, standard .NET controls that natively embed into the AVEVA System Platform technologies through the Archestra graphics. The last component then is what we call is kind of the integration component or the integration layer. So we're interfacing with site ERP systems, LIMS systems, and other database systems, whether it be Weighbridge, warehouse management, and so on, typically using standard OLEDB interfaces with robust handshaking for data transfer and reliability. So that kind of gives you the very high level picture.
Right. So, okay, so what is the kind of, that's kind of the high level picture of all the different components that you put into the solution. So the next question would be, okay, so what did you want to achieve? What was the benefits that you hope to get out of the system?
Okay. So there was a number of different benefits. So as I said, the project initiated as primarily a control system upgrade, or initially a control system implementation for a greenfields process cell, and subsequently control system upgrades for some of the other process cells in a particular site. So the overall benefit here was the standardization of the technologies. Traditionally in plants, what you had was the disparate SCADA and supervisory systems distributed out to the various control rooms of the plant. They were very much standalone, disparate systems, often running different softwares entirely or different versions of software supported on different operating systems, supported by different vendors. So you're talking multiple system integrator support costs, multiple license costs, trying to even track software and firmware upgrades constantly. It was
these kind of silos that it was operating in each section of factory plant was a different entity by itself, didn't work wasn't a unified system.
Yeah, and just managing that could be quite labor intensive. So the beauty of AVEVA System Platform was that it's a centralized model that can be then leveraged to build many SCADA applications essentially to multiple process cells, but all from a single centralized model with a single point of maintenance. The key benefit was that you now have a single standardized technology on a virtualized environment. So you're reducing your support base in terms of operating systems, reduced licenses, reduced number of support contracts to various software or system integrator providers. So it was that whole standardized approach. So the other side of that as well was that from a front end point of view, you also got a standardization benefit, which is that when the whole system is built centralized, you can now standardize what do our front end applications look like, what's their navigation speed. That whole UX, the user experience became standardized. So it meant that operators could seamlessly move throughout the site and with vastly reduced amounts of training could easily operate a control system in one process cell relative to another, because it's the same front-end system. It's the same scheme, the same principles.
And so I suppose the templatized approach of system platform allows you to do that rollout also quite rapidly. So once you've standardized, to continue adding more and more to the system becomes easier as you go along.
Exactly. But you're all the time you're maintaining that one standardized support base, which is, is a big win just from a basic management and maintenance of your systems on site.
Right.
So I suppose where that took us next is, I suppose, the reliability and performance, because again, when you're looking at disparate systems and you have these various, systems starting to age, operating systems, becoming unsupported, you start to have reliability issues with PC clients and the plant floor and things like that. And I won't say you have a lot of downtime, but what you have relative to the centralized enterprise system using System Platform, you have relatively a lot of downtime. So by centralizing your environment through System Platform, which has native redundancy options built into it, you're vastly reducing the impact of downtime due to hardware or software failure. And you have all this hot standby redundancy. So what I mean by that is, in your typical AVEVA System Platform implementation, you'd have a set of I/O servers, which are acquiring your data from your control system layer, feeding up into the system. You have your application servers, which are actually processing, running all that data, doing the hard work, as it were. And you have your terminal servers, which are distributing the sessions out to your plant floor clients.
Right.
Those sets of servers are set up in a redundant capacity with instant hot standby failover. So that gives you huge reliability in that for planned maintenance, you can schedule a failover onto your backup server with no impact on the plant floor. Production doesn't have to be scheduled to be stopped. You can perform maintenance on your servers, fail back in the event of a hardware failure or even a virtualized server failure, because they're still not impervious to damage or to wear and tear. You have that native hot standby redundancy that again is getting you out of trouble. So in terms of levels of downtime, you're talking a massive decrease there, huge reliability.
So it's really two levels that I hear you say there. It's the back end, that is the reliability of the back end, where all the data processing takes place with your redundant drivers, servers, but also for the front end processing, your terminals or your remote desktop or terminal servers are all in a redundant configuration, which means both for visualization and for data acquisition and processing, you've got that reliability built into the system.
And one of the lovely features you get is the concept of load balancing as well, where it's not that you must be running on your primary server or your backup server. Certainly from a terminal services perspective, you can actually distribute the load evenly across both so that your processing power is kept down. And again, just improved reliability on the whole.
All right. Your point number 3 there looks quite interesting, this hybrid approach that you're talking about.
Yeah, so I kind of alluded to that I described the SCADA and the MES as one holistic system. So that's not typical of a lot of production plants. In a lot of plants you go into, even where they have digitized and moved to MES from your real traditional MES, which was a man and a sheet of paper, even where you've digitized MES, where they're disparate systems, it creates workflow challenges, because if you imagine from an operator perspective, their primary driver is always going to be get product out the door. Product is where we make the money. That's why everyone's here on a Monday morning. So the natural workflow is always to get the process into steady state and then do the tidy up, fill out the paperwork, record the data, but it's retrospective recording of data. So
right.
By integrating the two systems together into one holistic system, what you have is that the operator now, as he's controlling his process, the MES and the SCADA as one system, the MES is picking up on triggers and events in real time as they're happening on SCADA and recording that information. So here you see, a very high level architecture. So what's happening is your SCADA system is, as you would traditionally have, acquiring and recording and monitoring data from your various control systems, and any hardware you like. AVEVA System Platform has a massive suite of I/O drivers that allow it to talk to Siemens or Allen Bradley or Mitsubishi, OPC servers like Kepware, or pretty much anything else you can think of. System Platform has a driver to do it. That is all then feeding into your SCADA. So if we take a simple example of an operator trying to run a milk pasteurizer, traditionally he starts up the pasteurizer, gets it to steady state and steady temperature, and then starts recording his data. Whereas now what's happening is the operator goes to his SCADA and he starts configuring routes. Immediately in the back end, without the operator even realizing it, it's now setting up product genealogy links between source and destination routes, As soon as he hits go, it's creating transfer records, it's logging initial temperatures, it's creating bookmarks in your history to say, this is now the, the temperature profile that I'm going to need to report on later. It's that holistic view. So the operator, without any change to his workflow from a SCADA point of view, has inherently taken a whole plethora of MES actions. So that's, sorry, go ahead, Dion.
So what you're telling me is that your goal is basically to let the operator continue doing his work as normal and let the MES become a natural part of that, of his normal workflow, his day-to-day work that he's doing.
Exactly. What the MES then also has is, obviously you have to tie into the database, which is where you're putting all of this data that's being automatically recorded. But you also have the integration with potentially other third-party bespoke systems or OE systems for feeding further information back to the operator to help them drive process performance. But also you've even practical applications, things like label printing or lab sampling. So if you know that 10 minutes into your process a lab sample is due, now that the MES and the SCADA are one in the same system, it's automatically generating, LIMS lab sample labels and prompting the operator on his supervisory screen saying, you must now take your sample. He's able to acknowledge that and go take the sample and send it on. The label is pre-printed with all the details or barcodes that it may need. If you're running warehouse management systems, you can integrate with those for consumption of raw material goods or receipt of goods into a warehouse and so on. So there's huge power there. The big one is the guy you see up at the top of your ERP. So again, your work orders coming down from your ERP layer, whether that's SAP, whether it's Epico or Infor, BPIX, whatever you have that integration. So that again, as the operator is taking his normal run-of-the-mill control actions, you might prompt him for things like, oh, which work order are you working against? And rather than that being write it down on a piece of paper, you actually present the view to him to say, these are the work orders for the day. Which one of these already presented to you is it that you're working against? So it's that closed loop communication from ERP down through MES and SCADA to the operator, distributed onto the plant floor and feedback back up the way as well.
Yeah, so if I think about this, it is normally that functions that you're talking about, that workflow of stuff that happens on the plant floor is normally facilitated by an operator, and it relies very much on the training and experience of that operator to actually bring all these systems together, because an operator would, in a traditional type of situation without a digitized system, they would have a spreadsheet, say, with orders that's coming from the ERP system, and they've got to manually transfer that work order that they get into the operation, into the SCADA system by hand, where here you've got a natural flow that happens in the system, and everything happens in one system, and you don't have to rely on somebody remembering to do something. The system prompts and the system makes sure that the procedures that needs to happen is actually followed, and that everything's recorded when that happens.
Yeah, and one of the beauties about it is that, why use AVEVA System Platform? Now, why not just do this with, AVEVA InTouch? Why move to the more powerful software? What it is that because AVEVA System Platform is leveraging that centralized model that you didn't have with InTouch, what's happening is that you now have one brain, if you like, that's monitoring all the various operator clients. So it has the big picture. If you were to try and do the same thing with standalone InTouch applications, what you have is every session that's running is trying to do the same processing. It's trying to keep an eye on, did one of the other sessions do it? It doesn't have that bigger picture, whereas your plant model is stepped back from that. So if you have, 3 sessions in the same process cell, maybe they're just distributed locations throughout the plant floor rather than a centralized control room. An operator can start the process on one SCADA screen, walk down the floor to another SCADA screen while he's doing his machine checks, for example, and continue the operation there. Your centralized model is managing all of that holistically.
So from a system point of view, a big step ahead for Lakeland Dairies. But what did it mean to them from an operational point of view? How did they experience the system?
So What you started to move towards then was that, you know, you start to have a little bit of change in workflow. You inevitably have that with a new system. And one of the big operational changes was that now that you have this hybrid SCADA MES that's automatically capturing data, you start to question the need for a lot of the paper that operators have to spend a lot of time transcribing. And to be honest, like, it's not their key function. Their key function is to get product out the door. So it's about streamlining that process so that they're spending more time on that and less filling out paper records. And what you start to look at, you start to realize that a lot of the paper becomes very redundant. So, you know, where guys were traditionally recording maybe a temperature every hour and monitoring it once an hour, now you have a continuous trend. So you're changing the operator from recording a temperature to prompting him to actually, you know, have you checked the temperature this hour? And it becomes a tick the box. Yes, I have done that. And what we started to move to was paperless manufacturing. So here you see an example of what we call, you know, our paper on glass log sheet approach. So what we found is that when you look at the paper log sheet, maybe, you know, 60 to 70% of what the operator was traditionally having to record and transcribe by hand is now happening automatically. So to ensure that guys are still monitoring things, and because there's two sides to it. It wasn't just a case of logging the data, it serves a second purpose, which is that the guys are actually reading it. To write it down, you have to have read it, so you're monitoring the system. So it's to present that, what was traditionally his paper log sheet, to transpose that onto glass, onto a screen, and automatically populate the data. You know, if it's hourly data, if it's shiftly data, once a batch, doesn't matter. But you present it to him in the same format that he knows and is used to. You know, where there's inevitably the few fields that you can't automatically acquire. Maybe it's an old school pressure gauge that's, you know, a glass dial on the side of a vessel. You know, you give him the facility to record that in the same place he would have done on paper, but now electronically. So what you're doing then is you're reducing the amount of operator training you need to use the new system. It's the same log sheet that he knows and loves for the last 20 years. He just now has a keyboard and mouse instead of a pen and a piece of paper.
So in terms of the change management for an operator, just made the transition to the new system was not difficult.
Exactly. One of the key benefits that actually gives you is that paper doesn't refuse ink. If I'm an operator and I misread something or I accidentally write down the wrong thing, no one is going to know that until, you know, later we go back looking at historical data and we read it and we say that value doesn't make sense. Whereas digital data, if I'm recording a numeric temperature and I have an expected range, I can pre-program that. And if I have a value outside tolerance, I can flag that to an operator and say, you know, this is outside your expected temperature range. You know, has there been a mistake made? You know, an operator may have just put a decimal point in the wrong place or typoed, for example. He can correct that instantly and the data is immediately right. So you've improved reliability. Where the data is genuinely outside range, it allows you to pick up on that event and take further action. Maybe it's, you know, reason coding like you would with downtime. Say, this is why the temperature is out of spec, so that now from a process supervisor and auditor perspective, looking at the data to say, yes, we have something out of spec, but here's all the detail on it as well. You know, there's huge power there.
Right, but which perfectly leads you into this whole, because in food and beverage, the big thing is traceability.
Yes. So that's kind of where you start to get the back end benefit of this paper on glass logging, is that from a front end point of view, it looks like the data is structured as it was traditionally done on paper. But from a back end, you know, you're plugging this now into a relational SQL database, you know, that's queryable, that you can, you know, pull data out into a format that can be trended, that can be analyzed. And, you know, you're really getting into the realms of, I know people like to use the term big data. I'd much prefer the term deep data, which is more, you know, more resolution, more instances of your key process variables and really analyzing those, as opposed to, you know, some people take the approach of big data of, oh, log everything and get lots of false correlations. You know, it's good. It gives them that deep structured data that allows them to really analyze and get value. From a traceability perspective, and even in terms of, say, speed of retrieval, the anecdotal one would be in a food and beverage plant. You know, if an auditor comes to your site, you might have, for example, 4 hours to pull together an entire batch back on a batch that you're not going to get until literally that minute. What you would have spent traditionally maybe 2/3 of your 4-hour window gathering your bulk data, you now have that in your first 20 to 30 seconds just by typing in a batch code and clicking go. And now it frees up most of your time to really delve into the detail that you need to. So it gives you huge power, both in terms of access, speed of retrieval, and the ability to generate new reports going forward. At this stage, it's very easy to take, you know, an existing Excel template that someone would have traditionally been transcribing data into once a week, spending hours. Let's now make that an automated report.
Right. And so kind of the big, if I can summarize the big three benefits that you talked about for Lakeland Dairies was, one, giving them a more reliable system. I mean, by introducing the system platform and thin client technologies. Then easing the operation, or improving operational effectiveness of operators on the plant floor, making sure that they do their job more consistently, more efficiently. And then for the third one is more from the management point of view, having traceability, being able to satisfy auditors, being able to conform to regulations, but also giving them that, what you call that deep data, that ability to really dissect and then analyze the data to see where there are places for improvement or opportunities for improvement.
The other key benefit that you get there as well that's worth mentioning is, you know, all that data that you're logging and recording, all these actions and events that are taking place, they're all attributable. What I mean by that is that the operator, when he logs in, when, you know, whether it's key fob login, for example, like we've done in Lakeland Dairies, or whether it's the username password, whether it's smart cards, doesn't matter. The logged in user, his username is now attributable to all the data that are all the actions that are taking place. So you have that granular level of traceability to the user, whereas traditionally you might have one sign off on the end of a piece of paper, but that piece of paper could be attributed back to several operators across a number of shifts, for example.
Now, this sounds all very good, but I'm sure with projects like this, everything is not just a walk in the park. There's most probably lots of challenges.
Plenty of those. So I suppose one of the first big ones is because we talk about the integration, you know, setting up reliable, you know, repeatable and consistent integration with systems, particularly when you're talking ERP, work orders and consumptions and receipts. Obviously getting that right first time is critical. So implementing handshakes. So whether that was through dedicated fields in SQL views with associated procedures for updating and, you know, stepping records through a series of statuses from not ready to ready to be processed, a process status, you know, known or caught error handled statuses, you know, if it's FTP of CSV files, that you have naming conventions, tries and retries on processing files, all this kind of stuff. So there was a lot of learning went into that, to be honest with you, Dean. It's, you know, it's something that sounds very simple on the face of it, but it's only when you get into the nuts and bolts of it that, and
it's the iceberg normally in a project is that integration story.
Exactly. But what we've now have, certainly for Lakeland and for many of our other customers as well, is, you know, standardized interface approaches and standard handshake models that we now leverage anytime we want to connect the system platform out to any third-party system, whether it's a mainstream ERP or whether maybe it's an internal bespoke performance analytics module that they've built in-house. You know, the technologies and the methodologies that we implement are now standardized.
So what you would say is it's a critical success factor when you do MES implementations is do not underestimate and make sure that you can integrate into your ERP system, else you won't get those kinds of benefits.
Exactly. You know, so I suppose looking at the next one was the implementation with minimal plant downtime. So what I actually mean by that was that, again, using the example of Lakeland, you know, their production schedule is quite heavy. You know, when you get onto peak milk production in the, you know, the late spring, early summer months, you know, you can't afford plant downtime. And to phase out a control system and MES implementations, such as we did across, you know, one of their sites in particular, you know, you really can't afford the levels of downtime that might be associated with a traditional build, pilot, and go live all in one hit, if you like. What instead the approach we took was, because we had these pre-existing standalone control systems, we were able to leave those in place, but also implement literally alongside them in the control room or at the operator station the new AVEVA System Platform control system in MES on a screen literally alongside it. What we were then able to do was, for example, pick a control, a control system within that process cell. So we'll say it's your milk pasteurizer. Lock out the control on the old system for that one piece of equipment and implement that one screen first on the new control system and encourage the operators to use the new system. Where you run into a challenge, you have an engineer logging on the old system that immediately re-enables it, so that if you run into a problem or a bug, the operator immediately diverts back to the old system. The on-call engineer gets a quick call to re-enable it. They drive on with the process, so no time is lost. And then you can spend your time diagnosing it. What went wrong? How can we bug check it and build it on that way? So it was a much more phased commissioning approach.
Right.
While it prolonged the project timeline, it meant that we never had a massive scheduled downtime or a traditional go live that you might expect with this kind of project. So from a production scheduling point of view, the implementation was seamless.
Yeah, one of the things I really like about System Platform in that respect is that it allows you to do phase deployment. You don't like have to do a big bang deployment of your entire project. You can do it bit by bit. So as you learn, you can deploy and correct.
Exactly. And what it meant then is, because you have this phase basis, you catch a bug in one process cell, you feed it back. You don't have those same challenges in the next one, because again, if you're centralized model and your single point of maintenance.
Yeah. Sorry, I forgot something. I don't have Andy today on the call, and he always reminds me that I've got to tell everybody, if you have questions, there's a Q&A section, and I forgot to do it up front, and I just realized it. So if anybody has any questions, please just post them in the Q&A, and we'll be happy. Well, Liam will be happy to answer the questions. Sorry, let's carry on.
No problem, Dion. I suppose moving it forward then, and we've kind of talked about this a little bit, was the business process changes. So you can imagine there's a cultural shift from an operator's perspective. He's a new control system, which again, we go to lengths to try and keep it very similar in terms of layout and general workflows, what they're used to. You don't want to introduce a lot of unnecessary operator training. In terms of electronic log sheets and MES functions, it was about making them look like the paper systems that they're traditionally used to. But also from a manager perspective, or if you're a quality person perspective, you have these new digital reports you're not used to using. So again, there was a bit of learning in terms of getting the exportability of data, getting that right, in the formats that the guys are used to, so they can, work with MES and work with System Platform as seamlessly as they did with traditional paper, but faster.
Yeah, it's, to me, in MES projects, is a great system integrator is one of the key skills that you should have as a good system integrator, is to not underestimate the change management and to plan for change management.
Yeah. And I suppose one of the approaches, and it feeds into the next challenge a little bit as well, is the concept that rather than, as you say, big bang deployments where there's way too much new stuff for anyone to really take on board, it was kind of phase it out. Again, this was a long-term evolving project where, we'd implement a bit of functionality, see where you're getting value, and let's evolve that to the next phase. Rather than trying to predict upfront as part of a CapEx project, the 150 reports you think you might need in the next 10 years. It was, let's develop the key ones, the key exportability of data, and what you probably find, in a lot of plants or in a lot of places, is what the guys are doing is they're exporting the bulk data, but they have Excel templates that they're used to using, and they start copy and pasting it in. And you say, okay, there's probably 2 or 3 Excel files there that you're using, day in, day out. Let's make an automated report that mimics that Excel file exactly as is, with, again, the exportability. So again, the guys are getting now within the system the same report that they know and love and that they're used to. So
Right.
That's scalable nature then as well. So
well, to me, the thing is when you start working in this MES kind of environment, is you need to think different from just the traditional SCADA way or SCADA way of thinking.
yes.
You're starting to think about enterprise applications instead of a HMI or SCADA that's running on a standalone machine. You're thinking of the wider impact.
Yeah, and that's one of the places where System Platform really comes into its own, is the template and object-orientated development model. So as long as you're thinking in the same space that you're alluding to there, Dion, right? As long as you're thinking, you know, generic, you know, reusability in terms of your object development, you can develop, you know, a generic template at a high level that's going to do probably 70% of the work for you. Maybe that needs to be tailored slightly in 2 different process cells, so you can derive in System Platform your sub-templates that inherit all the parent functionality of your generic guy. And you add that little bit of, you know, whether it's, you know, scripting or whether it's additional attributes, you tie them all in and you can build up a whole, you know, if you want, an enterprise suite of templates that makes the ability to scale out to potentially other sites or other process cells or new areas of the business. You know, you have all that engineering done up front that allows the cost, if you like, associated with a System Platform rollout. If you're doing like with like, as you scale out, becomes less and less the more you do, because you've done all the hard work up front.
Well, this leads us perfectly into your last point on this slide, which is being, it would make people that invest, or customers that invest in System Platform, really sets themselves up for the future to not just do the basic MES functions, but I suppose to do a lot more.
Yes, because I suppose one of the things that we should keep in mind is, as I say, we started on this approach with AVEVA System Platform as an MES platform, you know, 10 years ago, when it really was, you know, the kind of the new pioneering product for what was Wonderware at the time. But the portfolio has evolved so much in the last 10 years. You know, you want Insight come online, the model-driven MES, operations, performance, and quality, all these bolt-on modules, Skelta as a workflow product, they've all come into the portfolio. But when you look at model-driven MES, you see that the foundation is still System Platform. It's the same software. So what it allows you to do is, by investing in that as your base platform, you can expand up and you can start to take the modules that have real business value to you and bolt them on. You know, the value, you know, if there's modules that don't, you don't necessarily have to do that. And it ties in lovely with AVEVA's flex licensing model that you're now moving to as well. It enables guys to, you know, invest a little bit of capital, try something and say, no, that didn't work, but let's try something else that might work a little bit better. But you have all the time this core foundation that's going to stand the test of time, because the line I like to roll out about System Platform is that what it can't do out of the box, it has the power to be able to do it through a little bit of engineering and a little bit of configurability. So through your quick, you know, your quick script and your template development, your orchestra graphics, your embedded .NET, and its native, you know, seamless integration with SQL. If it doesn't do it out of the box, you can make it do it, you know, with a little bit of configurability.
Sounds very good. Well, but you need a good system integrator, of course. And of course, today we're talking to one of our top system integrators, NeoDyne, and you've had a lot of experience in this environment. Yeah,
so just, I suppose, a little bit of background about us. You know, we were founded in 1998 by Ger Helen, who's our managing director. And in, you know, the 20+ years, you know, we've evolved to a company of 120+ engineers and programmers spread across 4 offices in Ireland, you know, servicing industries across Europe, and even a couple of sites, you know, beyond again. Annual turnover there of, you know, approximately 11.8 million. You know, we've been a very organically grown company from, you know, I'm going to describe it as humble beginnings to, you know, to the company you see today.
Oh, quite amazing. So, and what's your specialities?
So what we have is, we have 3 different specialization groups, is the way we like to call it. So we have the system integration business, which is where I'm based. So that's everything we've been talking about in terms of automation systems, SCADA, MES, your IIoT, big data, cybersecurity, and so on. We also then have specialization in power generation and utilities. So guys doing, you know, embedded renewable generation, power generation, utilities plants. And we also have our, you know, again, a specialization in electricity and gas transmission and distribution, you see there. So they'd be kind of our 3 headline areas.
Well, that has been quite inspiring, I must say. I really enjoyed chatting to you, Liam. So thank you very much for all the insights that you provided to us.
Very much, Deanne. I appreciate the opportunity.
And I must say, well done on this project as well. I know the customers is very happy, and I think they've seen benefit of the partnership with you guys.
Yeah, we'd certainly hope so.
Okay, so once again, thank you to all of you that have joined. I see there's no questions. People must probably too shy to ask a question at this point in time. So all that we left to say is enjoy the rest of your day and live long and prosper.
Thank you. All the best.
Bye.